So here you're going to look at some of the vector data that we're working with in this lab. So your table of contents should look something like this. You're going to have this van DA 2016, van CMA CT 2016, and then you might have the raster data too. You don't need that on right now. We're not going to. So first off, you'll notice that the DA, which is dissemination area, and the CT, they cover different areas, and they're also different sizes where they do overlap. So I talked about this in a bit in module 1, or in module 3. These are different census units. So these census tracts just cover specific portions of the country, census metropolitan areas. So Metro Vancouver has its own CMA, census metropolitan area, and it has census tracts embedded within it. Dissemination areas, they cover the whole country, but we're just looking at the one for Vancouver here. But you'll notice that DAs are much smaller. So I'm going to show you how to do some things with the DA, and then you can just repeat them for the CT layer on your own. So if you open the attribute table, you'll see there's a whole bunch of records here. Each individual polygon within this vector data set has many records associated with it. So that's kind of the key advantage of vector data, is that you can have a lot of records associated with every single entity, whereas with raster data, it's one record per cell. And I'll talk about that later. But we got 3 that we're interested in: housing, income, and population. So let's look at the population first. So if we sort it, we see there's one really big one, and then most of them are a bit smaller. Sort it the other way. One little one, and then most of them a little bigger. But if we go to symbology, let's just make a plot of population, make a map. So we go to population, set it, and just leave it at the default natural breaks, or you can play around with different classification methods to see how it changes the way things look, right? Quantile does this. You want to clear this section, by the way. Quantile, equal interval, right? So I talked a bit about this one in module 3 as well, right? Look at how, right, we've got one big outlier here, and I'm going to show you how to explore that in a moment. But anyway, you can just go with natural breaks once you're done exploring. And we're going to create something called a histogram. So a histogram is a nice way to look at data. Again, something I mentioned in module 3, but if you go to create chart and click histogram, we'll bring up this window. And if you just select a numeric variable, population, it'll give you the tally of population counts grouped into bins, right? It'll list the mean. You can set it to show the median and the standard deviation as well. And so it'll list all those pieces of information. And so you can see, just looking here, right, we've got a couple outliers, which histograms are really good for spotting outliers. It's hard to see on here, but if you hover over them, right, there's these little blips down here that are, yeah, pretty hard to see, but you can kind of zoom in on them. So you can change the color if you want, if that helps you sort of see things better, for instance, to view the bins. So histograms are really useful for looking at counts, quantities, and helping you see outliers. So once you create that histogram, we're going to do another thing. We're going to create a chart or a scatter plot. So if you go scatter plot, we want to look at the relationship between 2 variables. Scatter plots are really useful for this. So we're going to set the x-axis to income and the y-axis to housing. And so you'll see that it comes up and it plots this relationship. And so by default, it should have this show linear trend on here, but if it's not, make sure it's checked. This R2 value, R squared, it's called the coefficient of determination. I've got some material in the lab under a note on linear regression. Make sure you read that. It's important. So I'm not going to explain that too much here, but basically R squared goes between 0 and 1. Closer to 1, the stronger the relationship. So you'll notice that there's some 0 values on this axis and 0 values on this axis. And if you explore this, especially looking at, say, income, for instance, there's lots of zeros. And there's some zeros for housing, some have values for housing and nothing for income, some have nothing for housing and something for income. And so basically, Stats Canada suppresses data if they don't get enough respondents to a survey within an area. So smaller units are more likely to have their data suppressed, whereas larger units are more likely, to have enough respondents. I think they need like 40 respondents per DA or something. But anyway, if they don't get enough people to respond to the survey, they mask the data out as a 0 value, which is not something that we want because that is just an artifact, right? Nobody is, say, making $700,000 or $70,000, but paying 0 for their house, for instance. So we want to exclude these. So we can go to select by attribute, create a new selection. Sorry, I had done this before, so it's already auto-populated, but you want to say where housing is greater than 0 and where income is greater than 0. The and is the important part. The and lets you string together multiple queries. So if you hit apply and then click or OK, you'll note that all the ones, these all highlight in cyan, but they also highlight on the plot, and all the ones that aren't selected don't highlight. And so you can actually quickly and easily filter out by clicking the selection button. Note how the plot itself changes and also note how the R2 value changes, right? So this is important. When we include, say, erroneous data, right? These are not correct. We are not getting an accurate representation of the relationship. But if we exclude them, then it shows the relationship in a different way.